Good morning. My name's Dan Bandera, and I am the president of the OSGi Alliance, and I'm here to welcome you all to the OSGi Keynote and also do a couple of award presentations. Thank you all for joining us this morning. I know it's a bit early. I think we had a lot of partying last night, so it's not quite as full as it was yesterday, but I'm glad you all could make it. In any case, I'll be around for the whole conference. If there's anybody who wants to talk to me about the OSGi Alliance or what we do, if you don't know already, I'll be glad to talk to you about that. But right now, I have the pleasure of presenting a couple of awards. We call them the OSGi Alliance Leadership Awards. And we give these out to organizations and individuals that have done something special, have worked extra hard in some way, shape, or form to contribute to our community. And so there's two awards this year, one for an organization and one for an individual. And I'm going to start with the organizational award. And this award is going to go to Huawei Technologies, who has really helped the OSGi Alliance on a number of initiatives. They've helped us find a presence in China. They're folks who are on the board, leading our liaison effort, leading our, co-leading our IoT expert group, and have reached out to other organizations like 1M2M, CCSA, and IIC. So that's a lot of work done by the individuals, and I want to present this award. Accepting this award on behalf of Huawei is Ruzbe Farhumand. And Ruzbe, if you could come on up. We had to do that for the photo. Of course, we had to take photos. Thank you for your patience.
Thank you very much.
Thank you, Ruzbe.
Thank you.
Now, organizational awards are important, and they're a team. But sometimes an individual has to do an awful lot of work to get one of these awards, because they have to stand out from a whole bunch of other individuals. And there is one guy in particular that has been helping us on a number of fronts, including, if you've seen the OSGi demo out there with the train, all of, well, not all, but a lot of the improvements that you'll see out there this year over what you may have saw last year if you were here are because of this guy. It's my pleasure to present the Individual Leadership Award to Tim Verbellen. Tim, you want to come up? Thank you. All right. Well deserved, and I'm looking forward to seeing who ends up getting those next year. And now, and so we can show, for those of you, I should have been putting these up. Any case, let me bring up and I think we need to go into screen show here. We have that up? Okay. So it's my pleasure to introduce the OSGi keynote for this conference, this joint conference that we do with EclipseCon for, I think, Ralph, 5 years now? But we have Emmanuel Xavier from Intel and Tim Ward from Primus talking about the journey, as the title says, from a monolith to a modularized application. And this is a journey that some of you might have taken and some of you have in front of you. I think this is going to be a fascinating presentation, and I'd want to welcome Emmanuel and Tim. Tim, Emmanuel, over to you.
Thanks, Dan. Thanks a lot for that great intro. And I also would like to thank all of you to join Tim and I today during this session. And I also thank the Eclipse Foundation, the OSGi Alliance, for the opportunity to be here and share some knowledge with you guys and exchange a little bit of information with you. This is my first time here in this event, so it's really exciting. It's great to meet such a great community of vibrant and passionate contributors, and so welcoming as well for somebody like me who is a newcomer here. Now, it comes to Monolith and modular applications. There's so many characteristics and so many things that are different that I could list here for you guys, but of course we have a time restriction. But there is a particular one that I would like to highlight, which is gratification. Now, there is this experiment from the 70s. It's known as the marshmallow experiment, and some of you might have seen it. If you're not familiar with it, I highly recommend that you look on YouTube because it's quite a funny one. So in this experiment, kids are given one marshmallow with two options. They can either eat that marshmallow immediately, or they can wait to get rewarded with a second marshmallow, and they wait about 20 minutes or so. So to me, a monolith approach to developing applications is very much like eating that first marshmallow, right? You get a little bit of that gratification, but it's really not fully realized yet. It's kind of an easy path to get to a goal. And building a modular application is very much like the second path, in which you have to put a little bit of more extra effort on that, but then you get a much bigger reward in the end. Now, as we know in software development, things are not black and white. There is a path from the first marshmallow to the second one. But then there's a couple of questions. Is it worth it? And more importantly to us here, how is OSGi able to help us to get that second marshmallow? So these are some of the questions that Tim and I are going to try to answer today as we describe to you this journey from monolith to a modularized application. And of course, not to break with tradition, courtesy of IntelliLegal. So when you look at the concept of modularity, it's not necessarily new. Like, it's been around for a while. We are all familiar with it to some degree. Not only that, but it also can be found in so many different areas: design, construction, processes, organization, technology. So the pool to choose from, an example of a historical reference, is quite diverse. The one we brought to you guys here today is about productivity. So in the late 1700s, Adam Smith introduces us to the concept of the division of labor, which is essentially modularity applied to productivity. He describes that by talking about the work of a pin maker. So when you don't apply division of labor, and a pin maker is now responsible to do all the tasks necessarily to create a pin, how much can you get out of that? Maybe you can get one pin, maybe up to 20 pins. Maybe if you hire a principal pin maker, a senior pin maker, depending on which company you're referring to, you may get 20, but if you hire a junior one, you would get one pin. And that's not a lot. Then when you apply the concept of division of labor, which is essentially modularity, right? The tasks that the pin maker is responsible for are smaller, they are more specialized, and they can now be executed concurrently. So we are all familiar with those concepts when it comes to modularity. So how many pins can a pin maker make when you divide the labor? According to Adam Smith, 4,800, which is a lot more than 20. Then later down the road, in the early 1900s, Ford introduces, again, the concept of modularity in productivity, but now we're talking about something a lot more complex, which is the production of a car. So in addition to use modularity, he applies automation to that. That's when we have the first moving assembly line being adopted. So with that, the parts of the car come to you. And the software developers, that's very similar to something we're familiar with, which is continuous build. And once again, the gains in productivity are quite significant. You can go from 12 hours to produce a car to 90 minutes. A few decades later, we see that concept showing up in software through David Parner's observations of modularity. The main themes remain the same, though: local knowledge and composability. The ability of changing parts of the software, parts of the system, without building the entire system once again, and we're quite familiar with that. There is another interesting point on that Parner's quote. It's the fact that he observed that modularity is applied to highly complex problems in complex systems. And I wanted to contrast that with a statement that we hear quite often, that modularity is too hard, maybe it's too hard to be worth the trouble. To that, what I wanted to highlight is that the complexity that David Parnas is talking about here isn't about modularity, it's really about the problem space that modularity is trying to address here. So what's complex is the problem, and modularity is what makes that solution possible, right? So for the naysayers that say that modularity is too hard to be worth it, I would say that do not mix the problem with the solution. So having said that modularity in software has been talking about since the 70s, we'd assume that today we have reached like the modularity nirvana. Tim, is that true?
Well, why don't we take a look at where we are today? So between 1970 and 2017, a lot's changed, right? We kind of expect that our spaceman that we had in 1970, 1969 we landed on the moon, we have our spaceman. So today we should have our cool spaceship that can fly between stars, right? That's what we've been taught to expect. Now the problem is we've ended up with a slightly different ship. And what we have here is something that is definitely still capable of traveling. It's definitely a lot bigger than what we had before, but it doesn't necessarily do everything that we expected, and it may not be quite 100% successful all of the time. And what we really want to know is, why is this the case? Why don't we have our super cool spaceship? Why are the ships something that we've kind of known about in terms of technology for quite a long time? They're bigger, and they maybe break more often. And the answer is that we have these things that are not magic. Modularity cannot fundamentally fix something that was broken to start with. It's a tool that you use to help make sure that you make something that isn't broken in the first place. What we did in the 70s was we realized that modularity was about trying to prevent coupling. It was about information hiding and making sure that things could be built independently. And there's a saying which is that those who forget their history are doomed to repeat it. Well, we forgot that lesson. We took all of these cool little modules, these things that were the first libraries, and we said, okay, well, we've got object orientation, we have class files, we have information hiding, therefore the problem is fixed. We don't need to worry about this anymore. And we forgot that coupling can just occur on the next level up. If your microservice, if you care that your microservice is implemented in Java rather than Python, you have coupling. And the problem is that this occurs all over our stack. Even the people who've thought about it really carefully at the low level, they forget that you need to repeat these patterns. And then we come across this and we say, oh, right, well, now we need to try and fix this. But it's too late. Once you've built a large coupled system, trying to add modularity later is hugely expensive, because you end up having to go through and make changes that cross the whole system, because everything is glued together. So obviously, this isn't something that just magically happens. You know, there's a pattern to these things. And what I'm going to do now is give you a little story. This is, you know, the recipe for a monolith. It's a little bit of project history. I won't claim that it's a project I've worked on, although I may have noticed some things in projects I have worked on. Maybe you'll see some things you recognize as well. Oh, and of course, it's a monolith, so I'm afraid we can't break it up. It only serves one person. Now, we have our beautiful new project. Everything is pretty and green and filled with flowers. Nobody wants to do this badly, right? We've all been here. We've got this greenfield project, and it's like, this time, it's going to be different. We're going to make it right. We're going to use Sonar. We're going to have 100% test coverage. We've got find bugs. I found this cool new AI analysis project on GitHub that claims it's going to make sure that we never, ever make a mistake. And we're going to use all of these things, and it's going to be great. We've got our well-defined set of modules in our build that we're going to use, and this is, you know, we're going to make it modular in our build, and it's going to work. This time, things will be different. And you know what? It kind of works. But the problem with things that work is that they get popular. And once they get popular, people want to use them, and they want them to do more things. So management have noticed this cool project that you've written, and what they want now is they want it to do more stuff. But of course, because they want it to do more stuff, they also have a deadline for that. So you've got 6 months to make it do this more stuff. Even though you may have spent like a couple of years on this greenfield thing, making it really, really perfect, you've now got 6 months to make it do twice as much. But it's okay, because management really love you right now, because you've got this cool thing, so you get more people. But unfortunately, as part of getting more people, you need to transfer one of your more senior guys, Carl. So Carl's this great developer. He's, you know, the project piece that he wrote, it's amazing. You know, it's full of all the best code you've ever seen. You don't always really understand it, but it's just so beautiful. And it's all going to be okay because we're agile. We've got these agile processes, and we know that it's all going to be fine because we can take on these new people. We've got an iterative model, so we've got our target in 6 months. We know what velocity we need to achieve, and it's fine. Isn't it, Emmanuel?
Not really. So your project's growing, right? You're almost there. You're almost finished with it. You have worked so many hours. We all have done that. Maybe there's a paper release around that that's kind of setting you up for a date that maybe you didn't agree with in the first place. But you've got all the process and tools in place, right? You've got code reviews. You believe that people are catching up with, you know, a great developer, Carl's, right? So you think that people are getting up there with his code. And, you know, to reach that date that you probably didn't agree with in the first place, you've put some workarounds in place, right? Who never did that? We all worked with workarounds before, right? But that's okay. We track them, and then we're going to fix them later down the road. We always fix it, right? We put a workaround, we track, and we fix. If you guys always do that, please let me know how you do it, because I have to figure that out. But things are starting to get red here. You see where this is going. So customers show up, right? 6 months, maybe a year down the road, and when you're planning to do all your workaround fixes, clean up all the mess you left there, you know, customers show up and they want more features built, right? But that's great because that means your project is succeeding, it's progressing, it's getting bigger, more complex. You got some new developers. It's not like you're gonna do all of it by yourself, but maybe you need to enter there 20 years worth of code in your code base. And then sales comes up and says, this needs to be finished in 6 months. So yeah, you got more developers, there's a lot of code you need to write, and you also got that headache of, once again, that hard deadline that you probably didn't agree with. And no one's familiar with that code base anymore, right? You've got those new developers, they don't know what was going on, they never met Carl, and they are now writing and adding all those lines of code to your code base. So what you end up with at this moment is a monolith. Maybe not a complete monolith, maybe a partial one. And it could be something worse too, which I call it a monolith in disguise, right? Carl was trying to write modules, so you might think this is modular, but because of all that mess, all those hard deadlines, and all that hard work that's in there, you may end up with something that you didn't plan to, you didn't intend to in the first place.
So, I don't know how many of you are familiar with Gall's law. Gall's law basically says that if you have a complex system, the only way that a complex system can exist is that you started with something simple that worked, and then you added a bit. Because it's really, really difficult to make something complicated from scratch. You need to start with something simple that works, and then you improve it. You add on a bit. The problem with that is that once things reach a sufficient level of complexity, any place that you try to add something on causes the whole thing to fail. And this is why you have to be really careful to manage complexity. Because your successful project is going to get more complicated. We can't stop that. That's progress. But what we need to do is we need to manage the complexity as it grows, because otherwise you will reach the point where you have this customer delivery and you've got 6 months to do it, and pretty much your only option is to say, we can't do this, we need to rewrite the whole thing from scratch because we just can't change it anymore. And that is a real problem, right? That is something that hurts productivity, it hurts business, and it hurts us, right? We don't like having to throw away the whole of something and start again fresh and rewrite all of that stuff over and over. We want to be able to change just a bit of it at a time. We want to get that quick win and see these things iteratively improving. So, actually, and just a quick show of hands, anybody recognize any of those things in the recipe for a monolith? Anyone had that kind of thing happen in a project that they've been on? Yeah, it's pretty painful, right? So, how OSGi helps also serves one, because you take one monolith and you can fix it. Now, you have your old-fashioned monolith, and what you can do is you can put it into an environment that is actually going to impose some boundaries on the monolith. So you had this intended modularity, and that's great. Intentions are good, but it turns out that when it comes to marshmallows, we're quite bad at waiting. You need someone there who's going to get ready to, as you reach for the marshmallow, say, no, wait, trust me, it's worth the second marshmallow. So we have this hiding of implementation details. Information hiding was one of the things that David Panos was really famous for kind of pushing, and it's like, this is the thing that modularity is about. It's about hiding information from other people so that you've got the things that they need to know and the things that they don't need to know. You can then automate all of this dependency management. For those of you who've seen any of the OSGi talks so far, some of the stuff on automated resolving, being able to validate things, you start to be able to do these kinds of things because you have an understanding of the structure of the modules within your system. And all of this is enforced. It actually makes you do it. And people don't always like that. It's one of the things that people don't like about OSGi is that OSGi tells you when you're doing something wrong. And normally we know, but we kind of push it down to the back. It's like the workarounds that we put in and we think we'll get around to fixing those later. You know deep down that you probably won't get around to fixing all of them, but you tell yourself that it's okay. OSGi tells you that it's not. And for better or worse, it's the way that you make software that works. And because it does these things, it lets you build these modular systems. What OSGi can't do is automatically take your monolith and make it pretty. It cannot do that. That is something that no tool can do. It requires you to do work to break this monolith up, to find the intended modularity and actually put it into practice. It really can't remove coupling for you. It can show you where the coupling is. It's very clear about where the coupling is, but it can't just get rid of it. You're the one who has to understand what it is and then remove it from your system. And then finally, it can't fix your API. The number of APIs I've seen where someone has clearly spent time producing an API, but they've not thought about what they are leaking through their API, what they've coupled to. The number of times that I've seen an API where someone said, oh yeah, and we're doing all this really cool stuff, and then you see that they're returning direct Guava collections, when really all they want is to return a set, but it's like, oh, we return immutable set. You say, well, why do people care that it's a Guava immutable set rather than just a set that can't be changed, which is part of the existing set API? You know, there are these kinds of things where you end up with your API becoming more and more complicated. And it's things like this that mean people complain about Maven downloading the internet or Gradle downloading the internet. The reason that that happens is because we tell it to, right? We're the people who set up those dependency trees. The dependency fanout is what we tell it to be. So we blame Maven and we blame Gradle, but the person we really need to blame is the person who decided to add all those dependencies into the file in the first place. And that's a developer. That's you, that's me, that's Emmanuel. That's who's doing this. So if you want to get results, you have to put in the work, right? If you want to be the big strong man, we know that the way that you fix that is you eat maybe slightly less and you do more exercise. We know that deep down. We want the quick fix, but I'm afraid the quick fix is to put in the time. So you need to plan and manage your API changes and be really careful about what your API does. And if you work with the tools rather than trying to work around them or against them, then actually you will get big wins. But you do have to go in the right direction. And it's an ongoing commitment, right? This isn't something that you do once and then it's fixed. This is a state of mind. This is a way that you look at your system. Modularity is something that you have to always be thinking about and always looking at in order to make sure that you don't move back to a highly coupled monolith. So OSGi, just like we were talking with the pin manufacturing, what you're doing is you're kind of limiting the complexity by splitting things into small pieces. So each of these small pieces may be quite complicated, but it turns out that the sum of lots of small bits of complexity is much less complex than one big thing which has all of the complexity in it. You know, that is a big deal. Particularly because you can divide and conquer by doing the work on these things, but you can also replace individual pieces more easily. You know, if you decide that you want to make this particularly complicated bit less complicated, more efficient, you can do that without changing the rest of your system. And that is a really big deal. Also, it becomes a lot easier to understand why Maven is downloading the internet. Because it turns out it's usually most things are okay, and then you've got one or two that have massive dependency fan-out. And those are the guys that hurt you. But you can never find out who they are until you have proper modules. Once you have proper modules, it's obvious. It's like, it's that guy's fault. And then you know where you need to go in and fix to get a massively improved speed of build or to get a massively reduced deployment size. And finally, you've got these modules. They're independent things. You can test them separately. So when it starts being, oh, we've got a problem and we need to write some tests, you know where to focus. You know what the thing is that you're trying to test. So this is really good stuff, right? It's not always that sexy, but this is how you make big software that works. So we've talked a bit about the background. We've talked some of the history of modularity, some of modularity in the current day. But what this keynote is actually about is it's about a real journey. So this is about taking an application called OSGi and applying modularity to it. Now, Emmanuel, you're one of the lead team for OSGi. Do you want to tell us about it?
Of course. So before we go ahead and start to decompose things and create modules out of OSGi, you guys need to understand a little bit what it is about and what it does. So OSGi stands for Open Security Controller. It is today an open source project. It's a Linux Foundation project. But it started as an Intel closed source project. And the main target or the main goal of this project is to help apply and deploying security functions on data centers and private or public clouds. So as it turns out, this problem wasn't specific to just Intel. It was also something that many of the security providers, security vendors we were working with were also facing. So what we decided to do was to extend it. But not just that, but also to make it an open source project, create an open community around that, so we could work with these vendors, these partners, and create something together. So in spring of last year, we started this open source journey, and the reason why that's important is because it matches with our modularization journey as well. And on June of this year, we released it as an open source project that's on GitHub. So as you can tell here from our story of the monolith, how you create a monolith, this is very similar, right? It's a project that had a certain scope. The scope increased, the complexity increased, the number of developers increased, and as a fact, the initial developers that were working on this project were no longer with us. So very similar to the recipe walked you through, but not just that, now because we open the code base of this software, we don't know how many developers will be contributing, right? It's not something that you can control. That's the whole point of making it open source. So it's very, very similar to that recipe. We are walking you through it. And the problem space that OSC relates to is what we call SDI. That stands for Software-Defined Infrastructure. It's just a fancy name for virtualized data centers and virtualized private and public clouds. So typically, on these infrastructures, you have a pool of resources. You're likely familiar with that concept. There's a bunch of VMs or containers, depending on which environment you're using. And then on the network side, you could have a virtual switch, a virtual router, a firewall, and then you have the storage resources as well. And those resources, they will expose attributes to what we call it an orchestration layer. That's the layer that makes your cloud and your data center dynamic. That's the layer that contains the typical controllers. You would have compute, network, and if you have worked with OpenStack before, they have specific names for each one of these controllers. And that's exactly the layer where OSC fits. It's a security controller that's essentially making sure that security functions, the security that you expect in your data center, is basically available everywhere in your data center, and it is applied as you expect it would be applied. So it's very similar to the compute, the network controllers that you might be familiar with, but it handles or deals with the security problem. So how does it do that? We're gonna go through a very simple use case here, just so we get an idea of the kind of actions, the kind of activities that a user would do when it's using OSC. So in here, we have, basically this is representing some workloads on your data center. These red ones here are the ones you intend to protect. To do that, OSC is gonna have to talk to your data center, and will also talk to the security manager and the SDN controller to be able to do all the network redirection to ensure all the traffic is going through and the security policies are being applied. So the user will do two sets of operations. The first one is what we call the one-time operation. That's going to allow OSC to integrate with all these other services. And the second set of operation will basically allow the user to set the security functions and apply the policies and define what he wants to protect in the data center. So let's walk through that step by step. So the first thing the user would do is register the plugins. Those are the plugins that will allow OSC to talk with these services here. And we'll hear more about these plugins as we walk through our journey. The second step is to basically register your VNF images. These are typically VM images, but now with containers as well that we're adding support to, it could be just a path to a Docker registry where you can find your image to your, basically your VNF container in this case. And then you create something that we call in OSC language a virtualization connector. That virtualization connector is going to allow OSC to talk to your data center as well as with your SDN controller. Essentially what that connector is just the IP address or the endpoint where your data center is, your data center APIs, and the credentials, the same thing for your SDN controller. And then you're going to be doing something similar, but you're going to be creating a manager connector that allows OSC to talk with the security manager. These are the one-time steps. You typically only do that when you're coming up with you register or configure a new data center or a new security manager or a new SDN controller. That typically doesn't happen very often. And then you get into the steps that you do to apply your security functions in your data center. So the first thing you'll do is create a security group that will now be able to identify the workload that you want to protect. The second thing that you're going to do is create a deployment. What that's going to do is take your images and basically deploy a VM or a container in your data center. The third and the last thing is to apply the security policies. When you do that, you basically say, I have this set of security groups, and then I want to protect this security group with a given security function using some policies that the manager supports. So you define all that setup. And what OSC will do, once you finish that, is to perform all the traffic redirection through your VNF, through your image, making sure that those security policies are applied. But as we know, of course, these environments are highly dynamic. That's one of the reasons why they are made virtualized in the first place. So workloads will pop up, and they'll change, they'll shift, they'll be migrated. As that happens, because of the way you define security groups, OSC will be able to identify that and automatically and dynamically protect any new workload that comes up and readjust all the network traffic for that. So that's, in a nutshell, what it does. There is a lot more complexity added there, like when you create a deployment, we actually deploy multiple VNFs, and that thing can get really complex. But in a nutshell, very simplified, those are the actions that you do. So what composes OSC? What makes all that functionality possible? It's actually not that different than a regular application stack. We've got a core where we have a bunch of business logic and synchronization tasks that make sure that all the data is consistent across all the services and systems. We've got a UI layer and the REST API layer. And observe, I'm referring to these as layers. We'll know why, because they are not actually proper modules. And then we have the set of APIs that we define to talk with the security managers and the SDN controller services. And the plugins that you upload there are basically implementing either one of those set of APIs. Then we also talk with OpenStack and Kubernetes. To do that, we use this set of dependencies for OpenStack. We use OpenStack4j. We use RabbitMQ to get notifications for OpenStack. For Kubernetes, we get bidirectional communication through this set of APIs. And these are some of the dependencies and frameworks we use on OSC, of course, OSGi, and H2DB, JPA, Vaadin, Logback. This is not a comprehensive list, but just to give you guys a flavor of what is in OSC. So now that you understand what OSC does, where it fits in your data center, what composes it, what our path to open source looked like, and like I mentioned before, this kind of matches our path to a modular application as well. So the first thing we want to do to be an open source project was ensure that it's vendor neutral. We want to make sure that we can work with various SDN providers, various security service providers as well. And we do have a plugin model. Like I showed you guys, we have the interfaces, we have the plugins. So this should be, in theory, easy, but it's not. That's when we start to first seeing some of dependency clashes that was essentially crashing OSC when we had plugins with versions that were not compatible and were essentially breaking, crashing OSC. We're getting class not found all over the place. So how did you solve that? The first thing that we thought along that journey before we got into OSGi was to maybe adopt REST services as the interface instead of Java interfaces, right? The issue with that is that we could standardize the interfaces, but then the partners we're working with, they will need to either change their endpoints or create new ones which would be redundant to what they already had. And then, of course, when you create these endpoints, there is the cost of creating it, the cost of maintaining it, and that's not conducive to have partners joining our community because the cost for that is quite high. Not only that, we also had some plugins, there were legacy plugins, that now we would have to change for that, and the OSC core code as well to adapt to this change. So as you can tell, the cost to go through this path would be quite significant. So what we did instead was, of course, using OSGi for this. And that's why we met our friends on Paramus that brought their know-how and help us through this path of first fixing the plugins problem, but then the journey starts, but it'll go on.
So, we have our story set. We have a plugin model that needs fixing. And it turns out, as we all know, OSGi is pretty good at this thing. What we need to do is to look at the dependencies and say, okay, where's this plugin API? And then we need to make sure that the runtime dependencies of the plugins don't conflict with the runtime dependencies of the core server. But again, OSGi can deal with that. That's why we have version ranges. That's why we can have multiple versions of the same package. And we can use a whiteboard pattern to communicate. So you see here we have the core OSC server, and there are two kinds of plugins, and we merely define what the API is, and then we can use the whiteboard pattern to consume these services. And it turns out that is pretty easy. We then also potentially have some startup ordering issues, but actually, again, OSGi solves this if you react to the presence of services rather than expecting the presence of services. Then startup ordering isn't a problem because you merely become a reactive system, not a system demanding things. But what we did have to do was to look at the plugins and say, these things are typically a bit too complicated to just be a single bundle. You wouldn't have your plugin be all in one bundle. Your plugin needs to be a set of bundles, potentially. And it certainly has some dependencies it needs to carry with it. So we did some work on creating what we call a bar installer, so just a bundle archive, a collection of bundles. But they're also indexed, so we can apply the OSGi resolver to them and validate that this thing makes sense and is going to work before we install it. So one of the other issues, as well as having these class not found exceptions because things were conflicting, is you only found that out at runtime, and you only found out potentially when it crashed your server. And that is not a good way to find out about issues. You want to find out about issues as you're going to install, and ideally before you've actually installed the thing. So that's what this gives us. And this is stuff that's being contributed back to the community. So the bar installer there's a proposal now to get it into Felix file install. So this is all open source stuff that's being given back. And you can see here contribution, and the whole thing, of course, is running inside an OSGi framework. So it took a little bit of time, a few months of work, just to make sure that we got everything correctly modularized and split up the build. But we came to it, it was done, and what do you know? All of these plugins that were previously causing problems could suddenly be used. And it turned out the benefits were pretty good. We actually, as a result of doing this, were able to throw out nearly half of the dependencies that were previously there. Because it turns out that when you use OSGi and you understand what your dependency graph is, you can look and say, well, about a quarter of these things aren't even used at all, and a few more are maybe used in 2 or 3 places, but it's duplicative. You probably don't need to use 3 different libraries to do things like collections, emptiness checks. You could probably just choose one and use that. So the thing became a lot smaller. It also became much simpler because rather than having all of this code to manage lifecycle, we were able to use whiteboard patterns. So we talked about this thing having a REST API and a web UI. Using the OSGi whiteboards to publish those things allowed a lot of the lifecycle code to just be removed. Deleting code is a good thing. If you don't need the code to do it, you've definitely got fewer bugs because the code isn't there anymore. And as I said, the plugin lifecycle was better because we were able to validate these things ahead of time. We could tell the user that the thing that they were trying to install was not valid or was built for the wrong version of OSC and prevent the installation from occurring before it had any effect on the server. And that was a big deal. So, very successful project. What do you think, Manuel? Did it work?
For what we did, it did work, but we're not quite modular yet, right? Remember that big core we're showing there? We fixed the plugin issue, but then what we do with the core? We did have a couple of things going on for our code base in the core that gave us the idea, the perception that we were modular, right? It's something that Tim referred to as the intended modularization, which is a good thing because at least you've got, at least your mindset going on somewhere that is indicating you believe that you've got some modules, that is indicating that you intended to have some modules in place. So a couple of things that we had implemented, object orientation was there. We had build enforcement using Maven, and we had an intended modular design. Whenever some design change came up, we made sure that whatever needed to land on the REST layer was in the REST layer, and on the core was on the core, and the database was on the database. But that was more an intention than a reality. In reality, we had all those modules inside of the core codepending on each other, right? So that's not a good thing. We also needed a higher level of isolation that object orientation offers us. And we needed that to be enforced at runtime. Some of the problems we have with class not found, it's not something that can be fixed by Maven. And we thought that what we're really targeting for was loose coupling. So the state that we're at is something that it's kind of similar to that idea of when you're blindfolded and you're walking and you think you're walking on a straight line, but then when you realize you're actually walking in curves. And that's what this picture is for here. The funny thing about this picture is I showed it to a couple of people and everybody sees something different. I heard DNA, I heard constellations, but this is actually from a study that tries to understand why humans walk in circles instead of in a straight line when they are not seeing where they're going. So that's very similar to that perception that you are building a modular application, but in fact, it's a monolith. It's basically what I was referring to as a monolith in disguise. Does it matter? Do we need to fix that core? We got the plugin problem solved, and now we're thinking about maybe fixing the core. Why is it important for us to do that? There's two main reasons for that. One is the problem space that OSC refers to, which is the SDN, SDI problem space, software-defined network, software-defined infrastructure, and the fact that's an open source project. So the interesting thing about this problem space is that it's still pretty new. It's not very mature yet. So a lot of things are still being defined, and you want to make sure that OSC can evolve with it. OSC can change and can adapt to it. So things like maintainability, extensibility, isolation, they're all important things for any project that you're working on, but they're so more important for OSC here because so many things are still being defined. Just to give you guys an idea, I was reading just a blog post another day about OpenStack and containers and all that, and there are things saying like, let's containerize OpenStack, but then there's other thought process that is, let's run containers on OpenStack. So even something so fundamental like that, there's so many ways that can be addressed, and the community hasn't yet figured out what's the best solution. So we want to make sure that OSC can adapt to these different situations. And when it comes to open source, we want to make sure that our code base is habitable. We want to make sure that we get healthy contributions, right? We don't want to be having developers shooting themselves on the foot with that. So things like unit testing, runtime enforcement, incremental build, that was a big gain that we had with this work. All those things are important to keep our code base healthy and keep our contributors happy. So yeah, the answer is it does matter. It matters a lot for OSC. I think it matters for any application, but if you're dealing with an open source project, something that's changing so much, those things are really, really crucial to the success of the project. All that to say that we are not done yet, and the journey continues.
So, we've fixed the plugins. What do we need to do now? Well, this thing we were talking about as the OSC server, it's what we in the OSGi Alliance call an Uber bundle. Now, an Uber bundle has a particular shape, and it's basically one big bundle that contains lots and lots of stuff, probably more stuff than it should. So in this case, the Uber bundle has the UI and the REST API and all of the business logic, oh, and the database access as well, all in one bundle. And as you can see, that's not very modular. And it's a flat class path in there. And it does that because you want it to be transparent what the dependencies are in there, because it's all a bit of a mess. That's usually the reason you have an Uber bundle. An Uber bundle is not something you choose to build. An Uber bundle is something that you build because you have to. And there's no isolation between all of these packages. So when you actually look at the way these things were coupled together, it turned out that pretty much everything talked to pretty much everything else.
And just to add to that, those errors are not comprehensive. There were a lot more of those. So like I mentioned, yeah, the dependencies between the modules were leaking all over the place.
Yeah. So the first thing we did was we said, what's the easiest thing for us to try to break out? And usually the best thing you can do is find one of the things that's a leaf. So things that the modules talk to, but that talks to very few other modules itself. And the database access piece was kind of the easiest one. It had very few places where it called out to other modules. So that was the thing that we chose to break out first. And so you pull it out of your Uber bundle, and you then have to fix up the places where this thing is communicating in the wrong direction. But we were able to get it to the point where the Uber bundle talked to this data access layer. And this was good. So we'd separated out all of the dependencies on Hibernate and H2, and those were no longer present in the Uber bundle. Those things were now separate and modular. So that was a good thing, right? The domain classes are in there, so these are the entity types. We've separated them out, we know where they are, and we can use Aries JPA to do all of the JPA work and persist these things, and nobody else needs to know or care how that's happening. So if later it turns out you need to use some NoSQL store, you can change that one module and nothing else needs to change. Good win. We used OSGi transaction control to help manage the transaction lifecycle. So this gave us a more robust system as well. And again, we were able to do that without having to impact the other components. And as I said, this is important. We have a unidirectional dependency now. Things may be all of a mess inside the Uber bundle, but people depend on the OSC domain. OSC domain does not depend on the Uber bundle. So the next thing we did was we found another component that we could try to take out. And so what we did was we took the UI component using Vardin, thought, right, let's get this working. So we had to create an API project. That API project defines the API for all of the business services. Because it turned out that while there were a lot of business services and there was notionally an API, there wasn't actually a way of talking to the business services without using the implementation types. And that was a problem, because it meant that the only way you could use the business logic was to directly couple to it. Once we introduced an API, we were able to use OSGi services to talk to this thing, and then we could have DS components that represented the UI views. All of this is then managed in OSGi terms. We can plug these things in and out very easily. We have a defined lifecycle. And once you've done it for the service API for the UI, it turns out that you can actually do very easily the same thing with the REST API. Because the API for the services is the API for the services. And this is why you chip things out one at a time. You find the thing that's easiest, move it out, and then you pick the next thing. And over time, it gets easier to remove more things because you become more modular. So you have JAX-RS service classes that are talking directly to your service API here. And you've got no more references to the domain classes here. We've actually got a defined API for talking to the business services, so you no longer are coupled to the database. These things have become pure API in terms of actually out to the programmers in the wider world, REST services and UI services. And these new service API and DTOs give you something which you can logically maintain and manage and version and understand what it is that you're really exposing between the modules. So the modularized OSC looks kind of like this. You have a bunch of different modules which have separated out the various roles of being a user interface, being a REST API, being the domain types. These are much smaller, which is a good thing. They have a clear contract between them. We use declarative services to manage all of the dependencies. So these things have become dynamic and easy to update, easy to fix. And because we've got a dramatically improved set of dependencies, it turns out that the build is a huge amount quicker as well. Because when you make a change, you don't have to rebuild everything. If you make a change to an API type, you change the things that depend on that API. If you make a change to an implementation type, you recompile only that module. So there were still a couple of things that weren't OSGi, and so we did have a remaining bundle that contained a number of libraries, but that bundle had dropped in size from 70 megabytes to about 3, which obviously means that it's a lot quicker to build and a lot easier to manage. So you will see that potentially as technical debt, but it's important to realize that this thing isn't just a one-off job, it's something that you keep doing. And because we'd got all of this working, we have our incremental build. So this is the stuff that those of you who went to the tutorial or have been hearing about the work that's happening in BND tools with Maven. This is one of the projects that got a big win from that. The incremental build works, you get proper recompilation, you get a system where you can make a change and see it running live in your framework, and it's actually become a pleasure to develop. It's one of the nice secrets about OSGi. Turns out it's a lot easier than it used to be, and the tooling's a lot better. So, Emmanuel, you obviously did a lot of work with Paramus over the past couple of years. You think we're finally there?
Not really. Once again, we got a lot of good things out of this work. I think incremental build was a big win for us. It used to take about 20 minutes to build the whole thing. Just whenever you changed like a unit test or made any smaller change, it was really annoying. But now with the incremental build, we got one of the biggest wins that we are going for with that. But the journey isn't finished yet, right? One of the biggest things that we learned from this is that it's something that goes on, right? It's something that you need to keep putting the effort on. You need to keep understanding your code base. So there are a couple of things that we still need to keep in mind, right?
Yeah, absolutely. You can't have the system modularized once and then not pay attention to it. This is an open source project. There are going to be commits coming in from all sorts of places doing all sorts of things. If you have a commit that starts adding dependencies into your API types, then very quickly you can end up coupled again. If you've got a commit that says, actually, the types that are in this bundle that's providing the persistence layer, we're going to start exposing some of the packages that weren't previously exposed. You've introduced the possibility that there's going to become bad coupling again. This is something that you need to understand and that you need to keep working at, to keep ensuring that your modules stay looking good, stay looking pretty. Writing good code is not something that you just do once and say it's done, right? Writing good code is a commitment to professionalism within software. It's a commitment to saying, I will continue to write good code, and when I need to make changes, I will do them in a way that maintains the structure of the program that I'm changing.
That's right. And modularization is something that you do one step at a time, right? Very similar to what we did with OSC, one piece at a time. So there's always a gradual approach to that. You have to see where the biggest gains are and tackle one problem at a time. But whatever you do not go back. Ensure that you have the proper enforcements in place, and OSGi is great for that and helps you to kind of hold the bar in place and just keep building on that one piece at a time. And OSGi is not a magic wand, right? It's not going to fix everything. It's not going to fix your APIs. You still have to put the work there, right? It will definitely help you to understand what you need to do, and it might be a little hard to begin with because it will show you all the technical debt that you have in your code base, but it certainly makes the job possible. Just so to conclude on that, to build a modular application, you need the right tools, the right frameworks, but more importantly, you need the right mindset. Whatever you do not go to the first marshmallow. Hold on to that and try to grab your second one, because I believe that is the right mindset, right, Tim?
Yeah, absolutely. You need to remember that every time you go for that quick win, that quick fix that you're going to get around to later, what you're doing is you are hurting yourself. And there's nothing more frustrating than being in a project where you've worked on it maybe on and off for a few years, and you look at it and you've got this bug, and you look at the code that you need to fix, and you see there aren't comments, and you see it's a bit of a mess, and it's calling out stuff all over the place. Your heart sinks, and it's like, whose fault is this? And you resist the urge for a little bit, and it's like, git blame, whose fault is this? And it's, damn it, past me. Why am I the last person who changed that line of code? There is nothing worse than creating problems for future you, because future you is the one who has to deal with them. And it's still you, right? It's the marshmallow thing all over again. You need to remember that future you is you, and giving him a reward is the same as giving you a reward.
With that, we thank you for joining this time with us. And hopefully with that, you can get your mindset, get out of that monolith cave if you find yourself in one. If you don't find yourself in one, try to identify that before you get inside and get that out of your way. Thank you very much.
Thank you.